This is the most sciencey experiment I've ever done. It involves testing my beers in an actual laboratory. So what are we testing? Well, fermenting lager yeast under pressure is purported to lower ester levels when fermenting at ale temperatures, creating a cleaner tasting beer. And I wanted to see if that was true for my German Helles Exportbier, which I'm splitting between two fermenters, one at 12 psi and one at ambient pressure. Are the beers distinguishable at a qualitative and a quantitative level? Cue tasting panels and some surprising lab results. This episode is sponsored by our Brülosophy Patreon members. More on that in a bit. So to help me conduct this experiment, I'm working with Devon Tanney from White Labs.
My name's Devon. I am the technical education coordinator here at White Labs.
As part of the White Labs Fermentation Society, White Labs worked with my buddies at Clawhammer Supply to create a blended yeast strain called Mythical Hammer, which is designed to create crisp lagers under pressure at warm temperatures. Higher temperatures mean faster fermentation, and pressure fermentation is purported to reduce esters and fusel alcohols. But before we do anything with the yeast, well, I need to make a beer. And this is my grist. I'm brewing a German Helles Exportbier, or a Dortmunder Export. Brewing a big batch, which I'm then going to split between two fermenters. Yeah, there we go. Let's get out the clumps. Big whisk comes in handy when you're dealing with this much grain. There's 22 pounds of grain in here, and the recipe for this is pretty simple. It's mainly Pilsner malt, so 20 pounds of Pilsner malt. I'm using modern Pilsner from Epiphany Craft Malts, and then to that I'm adding 1 pound each of Vienna malt and Munich malt. Now, why German Helles Exportbier for this experiment? Well, it's kind of one of those classic beer styles it's not super popular, just like as a drink you'd go and buy, even in Germany, but it is quite popular in homebrewing circles because it is a mixture of balance and subtlety and doesn't really give a lot of places to hide. It's a bit malty, a little bit hoppy, and if there are any esters being produced from the fermentation character, they should be quite apparent in a beer style like this. So this is going to be a single infusion mash, just holding it for an hour at 152 Fahrenheit, 67 Celsius.
How did it work with Clawhammer? They kind of came to you and said, we want our own yeast. How does it work? This is a blend of yeasts, right? Yes, it's a blend of yeast, but Clawhammer Supply is coming out with a new fermentation keg that should be able to withstand pressure. And from that, they're like, hey, can we get almost like an all-rounder yeast strain, the best of the best, to help ferment pressurized fermentation? We got some of our favorite lager strains, we combined them and forged this Mythical Hammer, which is now what you're brewing today. All right, coming to a boil now. So let's talk about what I'm going to do for hop additions. Main hop, I'm using Hallertau Mittelfrüh, classic hop for this sort of style. I'm adding 70 grams. This will give me around 21 IBU of bitterness. In this goes. I'm going to boil for 60 minutes in total, 10 minutes from the end. I'm going to add a few more hops just to give a little bit on the aroma and the flavor. So I'm going to add 20 grams of Hallertau Mittelfrüh again, and in addition to that I'm going to add 20 grams of Tetmang. I saw that the fermentation temperature is pretty broad for this, 50 to 64. So that's really warm for lager yeast. I think it could even go higher. What's crazy is, right, when you have ferment under pressure, you could actually raise the temperature. Some of these ferments, we raise the pressure to 1 bar, 15 psi, and we ferment at upwards, like sometimes even 68 Fahrenheit. So under pressure, you could actually go even higher. For non-pressurized, I would still err on the side of caution of more lager fermentations of at 50, 55 Fahrenheit. It could ferment at higher temperatures that you just might get other flavors present in that beer. So to the variable, it's time to do something different with these two batches behind me. I chilled the wort down and then split it between two fermenters and took an original gravity reading, and I got a reading of 1056. But now it's time to add the yeast, the star of the show today. So I have 2 of these Mythical Hammer yeast packets. Now, I did have a conversation with Devon about
how much yeast to actually put into this, because it's a bit of a quandary. Now, these are both lagers, and if you look on the packet here, it says 1 pouch for a 5-gallon batch, unless you're fermenting cold under 61 Fahrenheit or 16 C, that requires 2 packets, or if it's a high gravity beer. Well, neither of those things are true. I am going to ferment a little bit warmer than that, so Devon and I agreed we're going to go with 1 packet each. And as for the fermentation temperature, the recommendation is to go between 10 and 18 C, but Devon did say you could push that a bit further if you wanted. It's to my advantage to do that so that we're more likely to see a difference in the 2 beers. So I'm going to ferment this at 20 Celsius. So to add pressure, I'm using spinning valves. On the ambient pressure fermenter, I just have that spinning valve spun all the way open. So any CO2 that gets generated will just bubble out of there. So it acts as an airlock. For the other fermenter, I've tightened down the spinning valve all the way and then applied 12 psi of pressure and then gingerly loosened that spinning valve until it started bubbling and then just turned back a touch. So now I know I'm set at about 12 psi of pressure. As the yeast starts to generate CO2 during fermentation, anything beyond 12 psi, that will bubble away through the spinning valve. And these systems, I'm using Spike Flex Plus fermenters. They're rated to hold pressure up to 15 psi, and they have a pressure relief valve. Once you go over 15 psi, it's going to start hissing. So I do have kind of a backup to relieve the pressure should my spinning valve fail. All right, gonna leave this to ferment, maintaining the same temperature in both, but different pressures. See what we get.
Let me ask you for a prediction then. If I make this beer, this German Helles Exportbier, do you think there is going to be a detectable difference in the taste?
I believe there will be. What's crazy about lager malt bills and all that, there's not a lot of stuff to hide behind. So all those thresholds of flavor compounds really get shown through. By fermenting this lager blend a bit hotter at that 64, you might get some more esters, so then you might get other things that might cloud some of that cleanliness on the unpressurized. So I believe because it is at that 64 Fahrenheit, you will see a noticeable difference. My favorite thing is saying yeast growth equals beer flavor. So by having warmer temperatures, we're promoting yeast growth on the lager side. So it might produce more esters, more flavors on that unpressurized versus the pressurized.
Well, let's find out if Devon and conventional wisdom are correct. So after about 10 days, I took final gravity readings. The 12 psi beer had attenuated down to 1.007 and the 0 psi beer to 1.006. Close enough to be considered a tie. Now, I cold crashed and carbonated the beer and sent it off to White Labs for analysis. Now, I have to tell you, seeing my homemade beer being taken seriously in a laboratory was pretty awesome. And Devon talked me through the testing process.
So we were able to open some cans right by the flame and plate them on these microbial plates. These microbial plates are industry standard plates that grow common brewery contaminants to just double check for contamination on that beer, right? Just making sure your final product's not contaminated, not going to sour over time. Using isopropyl, plate some beers on and throw that in the incubator, see if there is any growth or not. Most of the time, what you want is no growth. So that's what we got is we were able to get 0 to no growth on our plates. There's no growth happening after throwing it in the incubator at 30 Celsius for like 5 days. This coming out as clean as possible was awesome to see, showing your practices, your brewing practices of being clean are clean. So that's always a nice safeguard. We have so many other tests too, like we have our gas chromatograph, which is able to take a beer sample and separate it into separate compounds. So the way I like to talk about this analogy is we're throwing a cheeseburger into this instrument, and then from the cheeseburger it's able to split into peaks of like the bun, the patty, the meat, the cheese, the lettuce, all in separate peaks. And that's how we're able to identify these certain flavor aroma compounds. From that, we could see diacetyl thresholds of like, hey, does our beer have diacetyl in it? Most of the testing, we need to make sure all the beer is decarbed, so those bubbles do not affect any of the results or readings of some of these numbers. We're also running some of our samples through our alkalizer. It's able to give us our alcohol by volume as well as specific gravities. It also makes a estimation of attenuation, spits out color, as we'll see there's a pH meter, and then our final one was just our IBU testing, but it's able to use inorganic layer, and you're adding some acid to protonate the isoalpha acids to move into this organic layer, and then you're able to read this layer or this liquid into the UV vis spectrophotometer, and you're able to get a reading, and from that reading it should give you an estimate of how many IBUs or how bitter that beer is.
Now, before we get to the results, a quick word about today's sponsor. If you're a fan of Brülosophy, consider becoming a patron of Brülosophy over at patreon.com/Brülosophy. By making a small monthly pledge, you'll receive rewards like access to unpublished contributor recipes, unique discounts at Yakima Valley Hops, and an invitation to a monthly live Q&A session with somebody in the brewing world, like Clay Disney from JD Brewing, the legendary CH from Homebrew for Life, and Brülosophy's own Will Lovell. Now, these beers went through a lot of different testing, and let's start with the sensory qualitative stuff. Now, I normally save this bit for the big reveal at the end, but I have so much data to share with you, so let's do this one now. I served the beer to 20 participants, splitting the beers across different coloured cups. Participants received 1 cup where the beer was fermented at 12 psi of pressure and 2 cups of the beer fermented at ambient pressure. A total of 11 tasters would have to accurately identify the unique sample in order to reach statistical significance, and a total of only 6 did, indicating participants were unable to distinguish a difference. But look, those tasters were blinded to the variable and didn't know what to look for. But I did. So I took the triangle test 5 times myself. I've had a few sips of this beer, both of them, but not much. So let's see how this goes. Yeah, I think maybe aroma's going to be my best shot. That's really good. I'd say blue's the odd one out.
Nope. Obvious.
It's obvious, you can tell right there from the smell. Yeah.
And they roll together.
Okay, just on smell alone, I think the red is the odd one out. Red is the odd one out.
Nope.
This is really almost a shot in the dark guess. I'm going to go with green.
Nope.
All right, I'm feeling lucky. Feeling lucky. I'm going to go with the smell again this time.
I'm going to taste it.
Not even, how about I do that? Not even taste it. All right. Oh, jeez. Green's the odd one out.
The aroma didn't work. Maybe you shouldn't smell it.
Yeah, not smell it. Okay. Red is the odd one out.
Nope. It's blue.
0 for 5, and more than any triangle test I've done, to me, this time, I don't even feel bad. These could be the exact same beer as far as I'm concerned. I cannot discern a difference between these beers. To me, this beer tasted clean with an ever so slight note of citrus, and I'm really happy with it. So, blind tasters couldn't reliably tell a difference. I certainly couldn't. But what about Devin? I sent him some cans, and he tried the triangle test as well.
For the triangle test, I was a bit stumped, actually. I actually guessed the wrong result for the triangle test myself. I thought the beers turned out really, really well. Both pressurized and unpressurized came out like a lager. Like, I would definitely be able to drink that on a nice summer day, or something that clean and crisp that I'm wanting a nice light beer for.
Now, Devin also put together a tasting panel at White Labs to take the triangle test.
It was our brew team, so most of our brew team, as well as some of our exec staff and our analytical lab.
A total of 7 people from the White Labs tasting panel took the test, of which 4 correctly identified the unique sample. But even then, it seemed the differences were quite subtle.
It seemed like, just talking with our taste panel group afterwards as well, everyone had a bunch of second guessing. Some people went with their first gut instinct. No one really had a defined calling card of like, hey, I know this one's the right one because of this trait.
So I think we can conclude that this German Helles Exportbier did not present reliably noticeable sensory differences based on fermentation pressure. but were the beers quantitatively distinguishable? Let's get into those lab results. Now, White Lab provided 2 sets of analytical lab results, one for each beer. The first thing I was curious to see was if the lab was seeing the same numbers that I was. Now, I recorded a specific gravity of 1.006 and 1.007, and the lab reported both beers had a specific gravity of 1.007. So, hey, I guess my little Anton Par density meter is giving readings consistent with White Lab's fancy Anton Par alkalizer. Overall, the 0 psi beer had an ABV of 6.45% and the 12 psi beer had 6.6%. Now, what about IBU? I've heard that lab IBU measurements can be significantly different from brewing software estimations, and boy was that the case here. Brewfather estimated an IBU of 24, but the lab reported IBU scores were of just 7 and 9. Wow. The BJCP guidelines for German Helles Exportbier specify an IBU range of 20 to 30, so my beers were well off. I don't know what could cause such a big discrepancy, nor do I know why the 0 psi beer had a slightly lower IBU than the 12 psi beer, although Devin did tell me fermentation differences could account for this. The beer was also a touch lighter than expected, scoring an SRM of 3.6 to 3.7, that BJCP guidelines state colour should be 4 to 6, and that my beer would be 5.1. So a miss here too, but not by much. Now, the analytical lab results have a bunch of other results, and let's focus on ones that had a noticeable difference between the 2 beers. And we'll start with diacetyl, a compound we certainly do not want in this lager. We'd want this well below 100 parts per billion, and that's the case here. Although interestingly, the 12 psi beer has higher rates of diacetyl. That said, anything below 50 parts per billion is likely to be below the threshold of sensory detection, so both beers scored well here. Amyl alcohols are fusel alcohols that can impart fruity or spicy elements at higher levels, and in keeping with the theory that pressure fermentation reduces fusel alcohols, we see that the 12 psi beer has lower levels of amyl alcohols than the 0 psi beer. That's also the case for another fusel alcohol, isobutanol, which scores lower for the 12 psi beer, indicating a cleaner, crisper beer. Other compounds scored low in both beers, such as acetaldehyde, a green apple off flavour, which scored well below the 10 parts per million threshold generally detectable by most people. And ethyl acetate, which can add fruity solvent aromas, also was likely below perceptible threshold levels in both beers. I think these lab results show both beers fermented pretty cleanly, although the pressurized fermentation did score a bit lower in the fusel alcohol tests, but as the sensory tests confirmed, not to the extent that these compounds were reliably distinguishable in the beers. To tasters, these beers were by and large the same. So a big thank you to Devin and the team at White Labs for working with me on these tests. I've included a link to the White Labs Fermentation Society in the video description, which is a free sign up to homebrewers, and from here you can keep track of their exclusive yeast strain releases. One big takeaway for me from this experiment is how low my IBU scores were for this beer. I used a hop spider for these brews, but perhaps throwing hops directly into the kettle would be more effective, and that's something I tested in this video here.